I'll give a... Good afternoon, ladies and gentlemen, and welcome to the Hydrogen Fuel Cells and Batteries Group Exhibit 2018. You're here with me today at the Technical Forum. I'd like to invite everyone who's listening to feel free to grab a seat, enjoy a coffee, juice, or water while we listen to the next presentation. I'd also like to say a quick hello to all of our listeners at home and remind our audience that the videos are available to watch after the fact. They'll be available from this afternoon onwards. Just head to our website, hydrogenfuelcells.com, look for the Technical Forum, and you'll be able to catch up on any presentations you may have missed out on. Our next topic is safety of hydrogen for mobile applications. And here with me today, we have the Deputy Chairman of DWV, Dr. Johannes Töpler. He previously worked with Daimler on the same application, so I'd like everyone to join me while we give Dr. Töpler a warm welcome.
Okay. Thank you very much for the kind introduction. And I think safety of hydrogen for mobile application is a very, very big issue, because people very often think, what about a hydrogen car if he is involved in an accident? And then some discussions about Zeppelin and so on will go on. But I can tell you that safety of hydrogen for mobile application is strictly regulated and strictly controlled by, by legal conditions. And the first I would like to show you is a hydrogen container. This is for a passenger car in principle for 700 bars. And you see vessels like this today here on the forum from different suppliers. The technology is ready for general application. It consists of a liner and an additional wrapping normally with carbon fiber. And here you see the so-called boss. And in this boss, the whole regulation and valve equipment is involved. That means that the pressure regulator is inside the vessel, and only low pressure, with exception of filling, is released from this container. That means in the case of accident, if some tubes are crashed, only low pressure hydrogen can escape, and then an active valve will close the container if the flow of hydrogen exceeds a very special limit. That's and now the valve system. Here is a valve system inside the tank with a regulator, so that only low pressure outlet, low pressure 10 bar or less, can be released. Another very important point is the so-called pressure-related device for release of hydrogen. It's a temperature-controlled pressure relief device. I will show you a little bit later how it works. Here is a whole valve head as we say, with all equipment we need to make the pressure lower than 10 bars. Here is a head once more and details of construction. It's very complicated, but the whole head from stainless steel has the force to remain in the tank in the case of an accident. And now the temperature controlled pressure relief device is a very new component. There are sometimes similar ones. This is a construction of a German company in North Rhine-Westphalia. In earlier times, we had melting materials, and sometimes if melted materials become soft or liquid, in the case of fire at high temperature, the material could refreeze within the escaping tubes, and they close these tubes, and this can be dangerous. And therefore, we have here a completely other system. You see here a glass capsule which is refilled with a very special liquid, and this liquid exceeds its vapor pressure at the special temperatures, and then the glass crashes, and this cylinder is pushed to the top, and hydrogen can release by these openings without any resistivity materials. And there are some very important points. And now the legal regulation is that raw materials should be tested, corrosion test before constructing, hydraulic pressure test, and here the burst test. I cannot show within 20 minutes all tests, but I will show the burst tests and some other ones of these tests which are necessary. And the burst test is a requirement that the minimum burst pressure should exceed the operating pressure by a factor of 2.35. That means that with an operating pressure of 700 bar, the burst pressure should exceed 1,654 bars, or specified burst pressures under other conditions which we will see in some experiments below. And you see here the burst pressure, the starting tank, the increase of pressure, and in this case, with this measurement at 1,954 bar, the container crashed 300 bars more than required. And this should be done by each construction with new experiments. This is a result of this test. And now we have some other tests, the cycle ambient temperature test. This is a cycle test at ambient temperature. And the cycle test requires then pressurized with liquid from 2 megapascal, 20 bar, up to 1.45, 25% more than working pressure, 3 times more than filling cycles for which the tank afterwards is improved, and there must be no leak. Absolutely no leak, 3 times filling pressure with more than 25% of pressure. Here is no figure, because at the end you have the complete tank who looks like a new one. The next one is the so-called chemical exposure test. Within a car, it can happen, for example, that the tank gets in contact, for example, with a battery acid, and the test requirements in this case are very severe. It has preconditioned by impact, and the impact is normalized, you will see it. The tank is exposed to 5 different chemicals. Then there are 5,000 cycles with 25% more as working pressure. Then additionally 24 hours remaining 1.25 times working pressure. And then in this special case, with this preconditioning, the burst pressure must be 1.8 more than working pressure. You see here the preconditioning the impact on the tank. You see it here once more in a bigger scale. Then you have here the damage of the tank before exposing to chemical, and here after exposing to chemical. And then you have 5,000 cycles with 25% more pressure. And then it has to be, the burst test should be 1.8 higher than the working pressure. You see here the different damages, the exposing to 5 different chemicals: sulfuric acid, sodium hydroxide, methanol or gasoline, depending on the fuel of the car, ammonium nitrate, and windshield washer. And here are once more the conditions as I have shown you in the previous shield. This has to be done as well. The result is similar than the burst test I have shown before. The next one is a bonfire test. And in this case, the following accident is simulated. Please imagine you have a severe accident of a hydrogen car with a gasoline car, and this gasoline car should be a tanker, and the tanker releases gasoline. The gasoline flows under the hydrogen car and then will be ignited. You will see it in an experiment. And then in this case, the tank is pressurized with hydrogen working pressure, 700 bars. The fire length is around about 1.65 meters. No burst, but venting through the temperature-triggered pressure relief device at a very special temperature. But up to this time, when this valve opens, the tank has to be absolutely safe. And I will show you now the film. Here is a prepared figure, how it works if the fire begins to burn. And then we have here the experiment. The experiment is significantly shorter. The time till opening of the valve is round about 5 minutes. We have reduced this time because I have no 5 minutes only for looking to fire. And you will see that after some time the valve will open, you will see it. And please imagine what will happen with a gasoline or diesel tank if you make this experiment. Now we look 1 or 1.5 minutes to this experiment. The time till opening is round about 5 minutes. Here it has opened. You see the hydrogen flame there. And this is a oh, no, sorry, it opens now. This is the most severe case. In general, for later working, there is a sintered material within the tube to reduce the velocity of the escaping gas. That's the test, and this test. Okay, the next one is a so-called bonfire test we had. And the next is a penetration test. It's a shooting test. Here you see a smaller container. Here is the target. Here is an automatic gun. Here is the automatic gun once more. And here is the shooted material. And you see now a film. This is before and after, outside. With wrapping, without wrapping, inside with wrapping and without wrapping, you see the hole. And now you see the film. It needs some second till shooting. The condition is that the tank will not burst. The hydrogen can be released, it's clear, you shoot a hole in it, but the tank must remain completely together. And now, that's another film. These conditions are internationally required. But the Americans don't believe that Germans can shoot. And therefore they make the same experiment with bigger weapons. That means bigger holes in the tank and a faster escape of hydrogen. You have seen it happens the same. No burst, no fire in this case. And finally, we had not yet any severe accident with a hydrogen car. But we had an accident with a natural gas car in the USA. Natural gas containers are similar constructed as hydrogen containers, but only for 250 bars. And here is a severe accident with a natural gas car. And here you see the complete container without any destruction. And the hydrogen container has a normal operating pressure of a factor of 3 more. And the burst pressure and so on is 3 times more as well. And therefore, I believe myself that the safety of hydrogen cars for mobile application are realized, and I believe in these cars. And I have driven a lot of them from Daimler, from BMW, from Toyota, and I feel more well in a hydrogen car than in a gasoline car. Thank you very much. And if you have questions, I wait for you.
Okay. Thank you very much for that presentation. Do we have any questions from the audience? Perfect.
Wolfgang Stein, you showed a lot of tests as a type test. What is necessary in the production to secure the quality of those tanks and to avoid scattering qualities?
I haven't.
This is a type test for a certain type of tank that you
yes.
showed. But if you have serial production, there might be other influences changing the quality of the individual product. What kind of test is required to secure the quality of that production?
The tests have to be done several times for each type of container, for each measure. You have to do the experiment from serial production with several examples. And in no case the required factor can be underlined. And the factor of, for example, 2.35 for safety, or 3 times for filling cycles, is a guarantee that nothing happens with a approved time or approved cycle numbers you can do. There are only additional safety factors in between.
All right, thank you so much. If there are any other questions, if not, I'm sure you can find Dr. Töpler at his booth. He is at C51. So if you have any questions or you just want to watch more videos of things burning, head on over there. Will you be here for the rest of the fair?
Yes.
All right, perfect. So
till tomorrow around about 12.
Okay, so maybe drop by today just to be on the safe side, or early tomorrow morning. I'd like to thank you all so much for your attention, and thank you, Dr. Töpler, for that presentation.
Okay, thanks.
So I'd just like to let you guys know that this was actually our very last presentation at the Technical Forum this year. So thank you all for being the audience members here. I hope everyone learned something, had a good time, and I hope to see you all again next year. Thank you all so much.